All right. So we had this brainstorm. I had shown in the previous video us loading bits into the what we believe is the XOB register, that extended operations buffer, and reading them back, and it seemed like it was being sort of flaky or inconsistent. And so we thought, well, why don't, instead of running the tape control test, we run those instructions and set bits into the buffer and read them back, and you know, hopefully we should, if we're looking at the right signals on the oscilloscope, then we should see changes happening. And the program's not actually running right now, but
I think I did just see changes from what Dawson is. Sorry, key again.
I did see a blip go by. I don't know.
I gave it the wrong instruction.
Okay, that might explain.
I will fix that.
Okay, so basically we're focusing just on the instructions that set what we believe are the XOB bits, and that way we should be able to see are we probing the right pins, basically, and that should help us hone in on the issue. So we're seeing.
So channel 2 is pin E1 on the TF register, so that's bit 0. So we can see that bit 0 is flipping back and forth.
So I'm just running with all ones in the accumulator.
Does not look good though. That's pretty gross. Hey Dawson, you should come look at this.
Purple is bit 0?
Yeah.
Aha! So this is kind of like exactly what we would expect given what we saw when I ran the program manually.
Intermittent that is.
So these should be the bits toggling in a loop, being set to the same value. So we really shouldn't be seeing that. It should just be a square wave, basically, right?
We
think. Oh, and notice how the green is.
Yeah.
I'm gonna turn off bit 0 and see.
Okay.
All right. Let's go back to live.
So bit 0 is off, and it stays off.
That's definitely the right bit.
So bit 0 is doing something really weird and inconsistent.
What about bit 1?
So bit 1 is off.
Can you turn off 0 and turn 1 on?
So yeah, the whole accumulator is 1s except for 0. I can just have 1.
So bit 1 is channel 3, which is currently low.
That's 0.
Now, was that possibly that bit that's unused in the XOB?
That's bit 2 that just turned on.
Okay. And it stays. Now, is there a reason? Okay, so you just turned on 0?
Yeah, that's really weird.
Okay, so when 2, can you turn 2 off and turn 1 on?
1 is on.
Okay, so, and turn 1 off. Okay, so when you turn 1 off, it goes high here.
Okay.
So turn it on, and it goes low.
I wonder if we might have the wrong pin.
Now turn 2 on. Now 2 goes high. Turn 2 off. It goes low. Now turn 0 on.
The interesting thing is the pins that aren't 0 stay high.
Yes.
Well,
right.
Sorry, I said pin, I meant bit. Bit 0 can't manage to do anything consistently.
Right. Now, but we don't know, is that something about how it's designed? Or, like, does some operation, when he's filling it, is it getting set to 0 and then he fills it? You know what I mean? Like, it could be something about the operation of that. But the fact that it's inconsistent, that seems like a dead giveaway that something's wrong.
As far as I know, all 3 of the bits 0, 1, and 2 should all behave the same because they're all the tape field bits.
Yeah. Yeah, I'm not saying that I believe that. I'm just trying to think about possibilities.
Sure. Just trying to find the page in the manual.
That is wild. So this is one of the things that I love about this whole project and dealing with an old computer like this is we're literally looking at individual bits being set in a piece of hardware inside the computer, and this one, which we think should be consistently on.
So Dawson
Yeah.
says he hasn't touched it, and now our pattern of, I don't know how easy to see that it is on the phone.
It
but
should be. I can see it in the view screen, but it's like it gets worse.
Yeah.
Or something.
It's not even.
It like gets
same.
really tired.
You should consider just popping that off and either putting a new M216 in there and seeing if it changes, or just changing the 7474 off the board.
Yeah, I would say try the other. If we have another M216, try that, or swap it out. If we're using this test where we're literally just exercising that part, I don't know. But I'm curious to see what you guys come up with, because that is wild.
I think you opening the door made it worse.
Is it now? We did have issues with it seeming like it was affected by physical perturbation.
Yeah, so Dawson is tapping on the case of the PDP, and now it's back. So, yeah, what I was going to say is it's interesting that channel 2 doesn't actually make it to the same voltage as channel 3. So
Yeah, I've got bits 1 and 2 off right now. I'll turn them on.
yeah, I think we might have channel 3 on the Q0 output of the flip-flop, but
That's possible.
Yeah.
it transitions when Dawson changes it, but it's the opposite of what we
Yeah.
expect. So we probably just have that on the wrong pin.
But either way, what bit 0 is doing is super weird.
Yeah.
You can hear it. It's really weird too.
Right, because bit 0, oh yes, so this is awesome, because the 0 bit is the bit that controls the speaker, okay? So I didn't even think about that, so that's why it sounds so weird. So I'm gonna come around here, and you can see it should be zeros, okay? Right, so if I change this to 0, it's 0. Change it to 1, you can probably see in the video that it's flickering a little bit, but if you listen to the sound that the speaker is playing, and the speakers, actually I'll come around the back since we have it open. Well, I'm not going to touch that. The speaker is basically right behind this panel, and I hope you can hear, it sounds like very static. It's not, and not like a white noise, but like a, how would you, inconsistent. It sounds kind of random, you know. So that is super interesting. So I think I'm going to stop the video here and let you guys swap hardware or do something else, and then we'll try it again. So thank you. This was super cool.